Hello. My name is Gene Bosman, and I'm an analyst. I'm Director of Infrastructure Research at Neurolytics, market research firm, and I'm Program Chair for the Software Defined Infrastructure Conference. And it's my pleasure today to introduce Kevin Conley to you for the keynote. Kevin is Senior Vice President at SanDisk and Chief Technology Officer of SanDisk. He's focused, of course, on strategic innovation. Prior to this role, he was Senior Vice President and General Manager of SanDisk Client Storage Solutions Group, a role which he had for many years until April. And he's, by the way, an inventor or co-inventor of 50 patents, but I'm told it's more than 50 patents. It's way more than that. In the area of non-volatile memory and architecture and management. He holds a bachelor and master's degrees from Santa Clara University, and he's a graduate of Stanford Graduate School of Business. So it's my pleasure to introduce Kevin and for him to come around. Thank you.
Thank you, Jim.
Thank you.
Good afternoon. So I'm up here to talk about something that I've always found one of the most fascinating aspects of what is driving the flash memory industry. As you might have gathered from my bio, I've been working in the flash industry for over 20 years. Most of that was SanDisk. And one of the things that I've been really interested in, especially not just as an engineer, but as a business leader, and now in the role as a senior technologist at SanDisk, is looking at what is driving the waves of disruption that flash memory has gotten behind. So I'm going to take you through that today, give you a thesis about it. It's going to keep things at a pretty high technology level, but hopefully that gives you some perspective into how I see flash as moving not just past industries, but moving forward in the future. So as part of this, because I am talking about the future, my legal team would like me to read this slide to you, which I'm not going to do today. Just don't do anything rash with your personal finances based upon what I might be telling you today. All right, so to understand what I see as behind the waves of disruption that we've been able to see, what flash has been able to do, have to get behind something that gives a different perspective than just talking about dollars per gigabyte. So starting way back when, we've seen flash disrupt chemical film. We've seen it replace floppy drives. We've seen it replace digital video and moving into digital audio and into MP3 players, putting thousands of songs in your pocket. Saw us even displace multiple of these as we enabled the high end of the smartphone market. And then today, we're very excited about what SSDs are doing relative to hard drives. In each of these waves of disruption, the key thing to pay attention to is not the dollars per gigabyte or the dollars per bit that we like to talk about, but it's really about the level of utility that flash is bringing when coupled with other technologies to each of these markets to understand when these markets topple over and flash becomes the dominant driver of those industries. Off this chart, if I were just to pick a few simple examples, looking at when chemical film was displaced, the tendency in the beginning was to talk about how much you pay for a cost of a picture, comparing a 12 exposure or 24 exposure roll of film to a compact flash card, talking about those costs, which is obviously ridiculous when you're talking about something which allows you to not only take unlimited photos and retake them when you take all those bad photos, but actually to be able to move those photos into the internet and to be able to share them. A totally different user experience, a different level of utility that they bring at a very efficient cost point. And so that's the principle that I want to introduce to you is the idea of cost utility. Another example is USBs replacing floppy drives. Even though you can compare these on a dollars per gigabyte basis, it's ridiculous to do so because they're obviously very different in terms of their nature and the benefits they bring. All right? So what we have to understand, though, before we go into looking at what this means in today's markets where flash is disrupting and where it's going to go in the future, have to understand a little bit about what's behind it. Okay? And that is where we look at the amazing ability of flash to scale over the past couple of decades. Flash has done an amazing job of being able to move to the next technology node every 13 to 18 months, and not only keeping up with the scaling of semiconductors that's been driving Moore's Law, but also able to move from single-bit technology to MLC becoming the mainstream to moving to 3-bit per cell technology. That has allowed flash memory to outpace Moore's Law and to deliver ever greater effective cost per bit as it moves through its life cycle. Now, it's a well-published and well-understood phenomenon that 2D NAND is reaching challenges in terms of moving from one node to the next. And despite the amazing amounts of innovation in cell design, in materials, in process, in the lithography of two-dimensional NAND, that it is getting to the point where delivering the next node in the right time frame is becoming more challenging. And so we've seen announcements both from SanDisk and others over the last couple of weeks in terms of where things are going for the future. And that's the concept that we take the problems that we're dealing with in scaling, in rapidly scaling 2D, and turning them on their side and introducing the concept of 3D. So all of this, So all of this has gone on over time, and we're going to go through this to deliver massive cost reductions in the raw media that flash is. As we go forward, understanding where 3D is going to lead us, we'll understand also what some of the challenges that this is going to bring for as well. So as Chief Technology Officer, I have to geek out, and so for those of you that aren't technical in the audience, I apologize. But I thought it would be interesting just to take you through why 3D is so important in terms of the industry and what problems it's actually solving. So what you see up here is a depiction of 2D memory. And as it scales, the tendency is for the cells to become taller, narrower, more closely packed together. And the thing to focus on is in these green areas is a depiction of the floating gates becoming more and more tightly coupled capacitively, both in the X and Y dimension. This is a key attribute to understand. There's lots of challenges to scaling from the quantum effects that we have when we get to very small lithographies and the limited number of electrons that are stored in these, as well as program and read disturb, which all contribute to the bit error rates of these memories. But understanding this capacitive coupling is key, because as you can see from the depiction in this bar chart, the effect is going off the scale. It's really becoming dominant in what we can deliver in terms of the reliability and also in the performance of these cells. So what 3D does is we come along and we turn that problem on its side. Now when we do this, we start to stack our bits in the vertical direction. And we also take things back a couple nodes in terms of where we look at the lithography. And what that allows us to do, and you can see it depicted here, is greatly reduce the coupling effect. We have it both smaller in the cell-to-cell in the planar direction as well as in the vertical direction. And the net result of all of that is that it takes us back to a much more or less effect from this proximity of these cells to each other, and thereby enabling the great increases that you've seen in projected reliability and also simplification in the programming and read protocols that are used on these memories, and hence delivering the promise of higher performance as well. Now, one of the things we have to understand is that this is very different. So if you didn't think that turning it on its side was enough of a challenge, just if you are familiar with NAND flash technology, you see these new depictions of what 3D flash looks like. And this is an artist's rendering of a close-up of that cell. You can see that this is very different than what we've seen in traditional semiconductors up to this point in terms of the way these are constructed and the way that they're operated. And so the challenges that we have are to try and repeat what was well understood scaling on a 2D basis in terms of maturing this technology, getting it to hit the optimal yields, and getting the capacity of these memories up from a production point of view so that they can deliver on the promises of delivering the economic benefits at the next node. So this is going to take time for us to get this to market, but it is, of course, the thing that we're most excited about and what most of you are excited about from a memory technology. The thing that we have to realize as we move through this transition is that 2D NAND is going to continue to be supplying the majority of the bits for the rest of this year and a good part of next year as well. And not only that, but it also is going to continue to address very large markets where the capacity gains that you get going to 3D are really not going to be of benefit, where they focus on lower capacity applications. So that's enough to understand that 3D is coming and is going to lead us to the future points of scaling over the next few years. So now I want to get back to this idea of utility cost. And what does utility cost mean in maybe more complicated scenarios to understand? Because when we go to where the future lies, it gets even more interesting. So if we look at what Flash has done for the mobile market. The mobile market, Flash has come delivering very low power, high capacity, high density storage, coupled with ever increasing CPU capabilities in these mobile phones. And as these smartphones have been developed, the LTE networks have brought high bandwidth and high availability of these networks everywhere we go. This has produced not just an interesting gadget from the confluence of these technologies, but has actually become an indispensable tool that we run most of our businesses off today. And the products that you see that have come out and what they've displaced in terms of feature phones of the past have actually come at a greater cost. So even though Flash has enabled this through lowering its cost per bit, the actual applications sometimes are more expensive depending on the amount of utility that they deliver. And as they go through this, we've actually seen huge increases in capacities that are being adopted into this. 128 gig just being the state of the art today, but going to even higher in the future as 4K video and raw image formats are brought into this. So that's pretty well understood. And we've also talked about something that was near and dear to my heart when I was leading our client storage business unit, which was hard disks being replaced by SSDs in our mobile platform. So the benefits of Flash from a performance, from a power point of view, as well as the reliability and mechanical stability that SSDs brought to these platforms were all great for us as users of these platforms, but also the industrial designers were completely freed from some of the form factor limitations that hard drives brought to them, and were able to come up with completely different interaction models in terms of folding, detachables, etc., ushering in the era of the Ultrabook. And as we went through these, something else was going on. We also have enterprises moving a lot of the data that we interact with to the cloud. That now is being coupled with movements not only in the enterprise, but also in consumer. So as you see, Windows has a brand new thrust on moving more stuff to the cloud. It really displaces the need for us to have terabytes of rotating storage in our mobile platforms. That all together have started the transition in large scale from hard drives to SSDs. This is happening largely ahead of where you'd expect in terms of comparing dollars per gigabyte. Again, I want to get back to that concept of it's the utility cost that matters here. To give you an idea of what I mean in a little bit more detail, look at an example where when we want to improve the performance of a traditional PC, the things that we relied on was stepping up in terms of the processor that we selected, perhaps putting more DRAM into the system. And a lot of people, especially traditional consumers, never looked at their storage, but really the storage was the bottleneck. And so I want to give you an example that underscores this. If you look at a typical high-performance system today using Core i7 processor with 4 gig of DRAM on a hard drive, you're hard-pressed to get that below a cost of $200, and yet you're delivering a platform which is very challenged in its ability to boot and to launch applications at a rate that most of us would accept. You take that same platform and replace its processor with a much cheaper and lower power, by the way, i5 processor, keeping the same DRAM but putting in an SSD to replace that hard drive. And what you have is a much greater user experience, over twice the performance of that previous system at less than half the cost. Okay, so here's a case where not only do you have better utility costs, but actually we're able to deliver it at lower absolute cost to the end user, which in this case is the OEM, who can then pass those benefits on to the market. It's going to be a while, of course, for consumers to understand these trade-offs. There's still a tendency to think bigger is better when it comes to your processors, your memory, and your storage. But the facts are that the era of the hard drive dominance those days are numbered. So if we look at this from an analyst point of view, this is one analyst's view of where things stand in terms of the cost reductions of flash from an absolute point of view. And if you want to measure utility cost, maybe I would pick sweet spot capacities of 128 gig and 256 gig. You look at those as they come down in price and they start approaching that sub $40 cost floor, which is that hard drives cannot get below. You can see that it's still quite a ways in the future where the rest of the industry topples over to these crossover points of 128 and 256 gig getting below those floor costs. And yet the adoption curves on what you see on the right here are what make most of us people involved in the flash industry very excited about this market, and a lot of the hard drive guys very nervous. I put it forth that actually while this looks very good, that it actually may be even understated, because we are seeing accelerations in the cost of these SSDs as new SSDs are introduced that don't include DRAM, that still deliver great performance at even lower costs. So that's something to look at as another example of utility costs, where we can really understand what's going on in flash and how it's disrupting the existing markets. It's unfair to compare these things on a dollar per gigabyte basis because they're really two different animals. All right, so let's talk about something which is much more interesting to most of us here, and that's to what's going on in the data center. In the data center, the challenges that you have and what the requirements are when architects are putting together their systems is looking at power, not just of the unit itself, but what that means to the overall power consumption of the data center in terms of supply as well as cooling. The performance that brings, the performance of your storage systems and subsystems, what those mean to your ability to supply the workloads that are put on the data center, the reliability aspects, the need to go in there and service the various aspects of your data center, storage being, of course, most critical there. If you look at just these three aspects, which were quite relevant also in those mobile and PC examples that we talked about earlier, SSDs are even more important here. And the reason for that is that they're applied at such great scale that the economics that are surrounding just these three attributes are massive. And scalability is really the key. That is our ability to meet the ever-expanding, not just user populations that are interacting with the data centers, but the expanding data sets that they're driving, as well as dealing with the physical limitations of scale. And then at the end of that, what we were really looking for is a way to support this economically. The build-out of and the investments in these data centers is absolutely massive. And so a way to keep up with the pace and these investments and really break through what today are economical challenges to doing that. So we'll talk about how SSDs are doing that. Now, one example is just to look at the replacement of high RPM hard drives in the data center. So hard drives, in order to deal with the latency challenges that they have tried to spin themselves faster and faster. You have 10K and 15K RPM drives going in for those high performance workloads, but they still have really significant latency challenges. The ability to reach the access densities that most data centers need is fairly limited. And now what you see with the advent of high performance, high capacity SSDs coming to market, you have the access densities of SSDs greatly surpassing those of hard drives. Take through an example pretty soon in terms of what that means to the enterprise. But this is a key aspect, and it's important to understand when you're looking at especially from a procurement point of view, of things which look and feel very similar in terms of being these standard form factor devices and wanting to compare those on a dollar per gigabyte basis, but you really can't, and you have to look at a higher level to understand what's going on here. Okay, so let's look at a particular example, and I won't go through this in tremendous detail. It's available in white papers if you're interested. But we took a typical application that a lot of data centers run into in terms of just a read-reference database and constructed a rack, a JBOD of drives, 288 300 gigabyte drives. And from that, you're able to extract a good 51,000 IOPS. That's obviously not great. When we can take a very high access density solution of 4 terabyte drives and build those into a similar capacity rack, what you end up is 1 million IOPS being supplied in a physical footprint which is less than a third of the original rack, getting that 20 times increase in the performance of the rack, as well as being able to reduce now the overall operational cost of that, because of course with this thing being smaller and cooler, it takes less power from your line, as well as less requirements for cooling. And you also have less requirements for real estate now, because obviously you're 1/3 the physical size. So the TCO benefits of SSDs have been discussed in great deal over the past few years. But now we're also getting to the point where if you take a look at what it costs to build that, you get to better economics overall in terms of the acquisition costs of that. And that's something that's very important to understand that doesn't pop out if you're just looking at hard drives versus SSDs on a dollar per gigabyte basis. By the way, those numbers are getting very close in terms of what those economics are, just on a drive basis. So now I'm going to take a next step. So going to from where data centers have been and the kind of decisions that people are making, looking to where they're going. So if we look at traditional IT, and what they're looking at is their challenges as they're trying to scale up the data centers that they're constructing. We look at typically underutilized servers in terms of the core compute that's being underutilized and trying to address that through virtualization. So virtualization has come in, and as it's been coupled with ever-increasing and quickly increasing compute power, we've seen the ability to deliver more out of our data centers at much greater economics, greater efficiencies in terms of how those CPUs are being utilized. However, it hasn't addressed the other aspects of both the storage utilization as well as the management plane of those data centers. So virtualization is something which has delivered economic benefits on the cores, but hasn't yet addressed storage. So we've seen now a new trend, it's over the last couple of years, and now really gaining traction in terms of software-defined storage and the software-defined data center. And the impact that that's had on storage is that we've seen several tiers come out to address how the virtualization needs have been supplied by different types of flash, but the high performance and the mid-tier as having toppled over from those 10 and 15K drives that we've talked about in the past. This, however, has addressed challenges as you virtualize your storage, virtualize the data center in terms of keeping up with the performance needs of these data centers and dealing with the efficiencies and the agility of this as we try to move workloads around. Okay, so I'm going to bookmark that, and we'll come back to that. Taking a look at another aspect of data centers, looking at a different category, which is really what has been driven from the web scale guys, what we like to call the hyperscales. Their architectures have focused more on scaling through converged architectures with their networks and their compute and storage. And as they build out in terms of trying to address larger and larger user bases as data piles up and trying to keep the responsiveness to their web applications, whether it be end-user web apps like Google and Facebook, or looking at things like Amazon Web Services for infrastructure as a service, the scale-out challenges of those have been massive. And in these build-outs, the efficiencies of these build-outs start to become challenged with just stepping out these traditional rack scale architectures, to the degree where you can look at a typical deployment in one of these data centers being 100,000 SSDs, just a 1% underutilization of any of those racks, and you end up with several petabytes of unutilized storage. So obviously these guys are very focused on the efficiency of these scale-outs and need to do something of that. So there's a new trend called disaggregation of these storage, which is leading them from more traditional rack scale architectures to rack scale where they're connected through high performance fabrics that allow storage to be disaggregated to larger pools of flash. Traditionally, for the most part, flash, to support the scale out. And what that does is that introduces new efficiencies, new operational efficiencies, both into the procurement cycles of these products in terms of addressing what is needed to not only procure but also to service these. What you have, it allows you to separate the cycles of those management from the CPU and the network, which operate at different cadences. So that's very important. But also, it brings us to new challenges as the bandwidth of these fabrics today is limited and affecting the agility of those data flows. Okay, so we looked at now two different paths of evolution that our data centers are going through, addressing different needs at scale for the enterprise and for the hyperscalers. You had the enterprise going the virtualization route and running into the challenges of performance and agility of their data centers. And then on the flip side, you had the web scale guys with the rack scale architectures coming out and running into the challenges of both the management of the scale, as these guys have built out their data centers, as well as the bandwidth challenges that are coming. Now, as these evolutions are happening, you're looking at bleed over from one onto the other. You have, on the one hand, disaggregation happening on the right, but also coming in on the left side, and you have the scale out of you have the virtualization and the DevOps activity on the web scale. Impacting how those architectures are going. These two things are rapidly converging into a future where data centers will have virtualized, disaggregated storage that will be tuned to the needs of these data centers. And we've at SanDisk, we've talked about solutions that optimize things like Ceph for the enterprise, which rely on the types of disaggregation that the hyperscales have been looking at. So this is a very interesting paradigm that's happening, and it creates a really interesting future for flash storage where we have huge pools of flash that are going to be serving the needs of these as we move into a more public cloud-dominated infrastructure as a service world. Now, what does that mean for flash solutions themselves? So in traditional architectures, it's been fairly easy to pull out that 2.5-inch drive and stick in a 2.5-inch SSD, getting the benefits of performance, power, and reliability from just doing that one-to-one swap out. But this is a legacy view of this. Looking at SAS and SATA, that's yesterday's game. Even as we move to PCIe, we're still talking about more or less replacing hard drives with SSDs. And so again, it's very easy to fall back into wanting to look at those on a $1 per gigabyte basis. But what's more interesting, if we look at the benefits that flash is bringing and the massive amounts of performance that are underutilized, is to start looking at what happens when you start touching the software associated with the applications and the higher levels of the software stack in dealing with that storage. So if, for example, if we take high-performance PCIe storage, put it close to the CPU, and start introducing software optimization, what you have is a large increase in the application performance at sometimes higher cost, but it's such that you're able to accelerate and reduce the needs for CPU and storage overall. So bringing, again, some of those TCO benefits. Now that's introduced a lot of interesting things. So what does it look like when we start to move into an era of disaggregation, where we want to start having those operational efficiencies of managing flash in large pools? So there we start seeing flash appliances come out, all flash arrays, which allow you to not only deal with the operational efficiencies of procuring and managing flash, but allow us who are focused on delivering the solutions of truly delivering optimized economics for these applications, delivering very, very high capacity solutions that deliver the type of responsiveness and the low latency required for these data center applications. So when you roll this all up, what should be the key takeaways, and what do I want you to take away today? The first is that 3D NAND is here, and it's going to drive the future of our industry to continue the types of waves of disruption that we've seen to this point, delivering new levels of cost utility. That transition will take time to hit every single of the market segments that we're looking at. So when we look through what are the solutions today that are going to be driving most of the industry, it's really still 2D in those 10 nanometer class of applications or of products that are going to be driving this. The second is that flash utility cost is today already at the point where it's driving massive adoption in the data centers and has been able to enable flash to be deployed at scale in a lot of these very, very demanding environments in the data center. And lastly, disaggregation, this trend that will drive the future of where data centers are going, is going to create the opportunity and high demand for very high petabyte class storage products that address the scale-out requirements of exabyte deployments in data centers. And so with that, I will conclude. Thank you for your attention today. I'll be available for questions a little bit later. And if you're interested in what we're presenting on a product basis, please stop by the SanDisk booth. You'll be able to see demonstrations, first of all, of our first publicly shown 3D-based products, both SSDs and other consumer products based on 3D memory, as well as some of our new data center products, such as our Cloud Speed Ultra second generation products. That'll be on display there as well. Thank you very much.
Thanks very much, Kevin. Thank you very much.
Thanks, Gene.
Appreciate it. Great talk.